Hi, dear students, welcome all. You know, necessity is the mother of invention, so it's the high time for a digital lectures. That is why I am giving lectures in digital platform. It's a new experience for me. In this pandemic situation of coronavirus infection, not only Bangladesh but also whole world is going through a devastating situation. We must be fully conscious for our safe health. Hopefully, we shall overcome this situation very soon. Now, let's come on my lecture topics. My topics is heart rate and its regulation. Now, I like to introduce myself with you. I am Professor Dr. Abida Ahmed, Professor of Physiology. Now, at the end of this lecture session, you will be able to know about what is heart rate, normal heart rate in different age group, maximum heart rate, factors affecting heart rate, and regulation of heart rate. Now, to know about the heart rate and regulation of heart rate, we must know about the nerve supply of heart. Nerve supply of the heart by the autonomic nervous system. Autonomic nervous system are two, sympathetic and parasympathetic. Parasympathetic nerve supply through 10th cranial nerve, that is through vagus, and sympathetic nerve supply from sympathetic chain of lower to cervical and upper 6 thoracic cranial nerves. Look at the diagram that this vagus nerve, right vagus nerve and left vagus nerve. Right vagus nerve supply SA node and left vagus nerve supply the AV node. Now, vagus nerve, they extensively supply SA node and AV node. That is, the vagus nerve or parasympathetic supply, they control the heart rate predominantly. And observe in this figure that sympathetic nerves, they supply ventricles, and for this reason sympathetic nerves control the force of contraction. Conclusion of this diagram that vagus nerve or parasympathetic supply regulate or decrease the heart rate predominantly, and sympathetic nerves increases the force of contraction, that is, it controls the force of contraction predominantly. Now, heart rate. What is heart rate? Heart rate is the number of beats by the heart in 1 minute. Normally, heart rate is equal to number of cardiac cycle in 1 minute. That is also the pulse rate. Heart rate is one of the important indicator of cardiac rhythm. And another information about heart rate, that heart rate is inversely proportional to the size of the animal. Elephant is a big animal. Therefore, heart rate is in elephant is 25 per minute, and heart rate in teeny bird is 1000 per minute. Normal heart rate in human being. Normal heart rate in adult human being is about 60 to 90 beats per minute, and average heart rate is 72 beats per minute. Now, what is maximum heart rate? Maximum heart rate, it also has important clinical significance. Maximum heart rate, that means by knowing the maximum heart rate, we can assume about the capability of the heart to its maximum heart rate. It's important for testing of the capability of the heart when we test it in treadmill. Now, the definition of maximum heart rate: the age-related number of beats of the heart per minute when working at its maximum is maximum heart rate. That is usually estimated as 200 minus one's age reached 90% of the maximum heart rate when tested on a treadmill. That is, on an assumption, if we deduct age from 2 to 0, then it will represent the 90% of the maximum heart rate. For example, suppose a person having 60 years of age, then 220 minus 60. 220 minus 60, that is 160, is the maximum heart rate. But for accurate calculation, there is a formula for calculation of the maximum normal heart rate. This formula is 208 minus 07 into S. Now, maximum heart rate. At 20 years, it is about 20 beats per minute. At 30 years, 190 beats per minute. 35, 185 beats per minute, and 40 years, 180 beats per minute. The conclusion is the maximum heart rate is highest at 20 years and gradually it decreases with advanced age. Now, what are the factors which affect heart rate? These are age, gender, body temperature, drugs, diseases, emotion, exercise, metabolic rate, respiration, and intracranial pressure. Now, emotion. What are the emotions? These are excitement, anger, anxiety, and grief. Now, heart rate in human being in different age group. Now, at birth, it is about 130 to 140 beats per minute. Up to 12 years, it is about 100 beats per minute. In adults, 60 to 90 beats per minute. In old age, up to 100 beats per minute. Conclusion of this chart, that is, with progressive age, the heart rate decreases, but exception in old age. In old age, according to this chart, heart rate should be decreased, but it is increased. What is the reason? Because in old age, the elasticity of the arteries decreases. For this reason, there is slight increase in heart rate. So, in young adult, what is the normal heart rate? It is about 60 to 90 beats per minute. Now, what is the effect of gender? In female, heart rate is slightly higher than the male due to decreased blood pressure, higher resting sympathetic tone, and lower hemoglobin concentration. Now, what is the effect of body temperature on heart rate? Body temperature, that is, in increase of body temperature of 1 degree Fahrenheit, heart rate increases about 10 beats per minute. And if there is increase of body temperature 1 degree Celsius, heart rate increases about 18 beats per minute. Now, effect of drugs and diseases. Drugs like epinephrine increases the heart rate due to direct action on heart. In thyrotoxicosis, that is increased thyroid hormone, there is increased heart rate. Emotion. What is the effect of emotion on heart rate? Emotion are excitement, anger, anxiety. These types of emotion increases heart rate, and sudden mental shock and grief decreases heart rate. Now, effect of exercise and metabolic rate. During exercise, there is increased heart rate due to increased sympathetic activity, increased metabolism, and increased body temperature. When there is increased metabolism, then there is increase of heart rate. Now, what is the effect of respiration? In respiration, that is during respiration, heart rate increases. Increased heart rate during inspiration is called sinus arrhythmia. It is very often found in healthy children. In adult, it becomes prominent after deep voluntary respiration. Now, what are the causes of sinus arrhythmia, or why during inspiration there is increased heart rate? You know that during inspiration there is negative pressure in the mediastinum, and due to negative pressure there is increased venous return and increased heart rate. Now, increased intracranial pressure slows the heart rate by directly stimulating the vagus nerve. Now, regulation of the heart rate. Heart rate is regulated by two mechanisms. One is extrinsic mechanism and another is intrinsic mechanism. Extrinsic mechanisms are nervous regulation and humoral regulation. Nervous regulation, again, autonomic nervous regulation, regulation of heart rate by reflex action, regulation of heart rate by higher centers, regulation of heart rate by the nervous system. Now, nervous regulation of heart rate by cardiac centers in the medulla oblongata, autonomic nervous system control heart rate. Parasympathetic nerves affect heart rate significantly, and parasympathetic stimulation decreases heart rate and sympathetic stimulation increases heart rate. That is conclusion. Cardiac center present in the medulla oblongata, that is autonomic nervous system, that control the heart rate. Now, parasympathetic nerves by the vagus nerve and sympathetic nerves by the lower two cervical and upper six thoracic cranial nerves. Reflex regulation. What is the reflex that regulate heart rate? They are the baroreceptor reflex. Another name of baroreceptor reflex is Mary's reflex, chemoreceptor reflex, Bainbridge reflex, Cushing reflex. Pain sensation from peripheral nerves reflexly increase heart rate. Now, higher centers. One of the important factors of nervous regulation is the higher center, that is stimulation of the motor cortex, frontal lobe, thalamus increases heart rate, and the stimulation of limbic system as in emotion, that also increases heart rate. Moderately painful stimulus generally quicken the heart rate. Stimulation of the central of the fifth nerve of the splanchnic nerve slows the heart rate, and sudden blow on the abdomen may stop the heart rate. Now, in your prof exam, there is a question: what are the reflexes that regulate or that control heart rate? These are the reflexes that regulate heart rate. That is baroreceptor reflex, Bainbridge reflex, chemoreceptor reflex, central nervous system ischemic response. This is expressed by Cushing reflex, and reflexes from other parts of the body. From other parts of the body, that is the pain from peripheral nerves that increases heart rate, and sudden blow on the abdomen that decreases heart rate. Now, humoral regulation. What are the humoral factors that regulate? What are the humoral factors that regulate heart rate? There is adrenal, for example, adrenaline and thyroxine. Adrenaline, since it acts like the sympathetic nerves, it increases heart rate. Thyroxine, it quickens the heart rate by directly stimulating metabolic rate of the SNOT, by increasing the BMR of the body, by stimulating effect on sympathetic nervous system. Actually, humoral regulation, that so many humoral factors that increases heart rate and decreases heart rate. Important example, adrenaline and thyroxine. Humoral factors, that is the different chemical factors that are released in the circulation in our body. Intrinsic mechanism of regulation of heart rate. Heart can also regulate its rate by its intrinsic properties. One of the intrinsic properties you already know from the properties of the cardiac muscle, that is a Frank-Starling law of the heart. Another is Bainbridge reflex. Now, intrinsic cardiac regulation means the changes in the heart rate in response to change in the volume of the blood into the heart, and also the intrinsic properties, that is intrinsic properties of the heart that are not related with the nerves. This is the inherent properties of the cardiac muscle. One of the intrinsic mechanism, that is the Bain-Briggs reflex, also called the atrial reflex. It is an increase in the heart rate due to increase in the central venous pressure. Increased blood volume is detected by stretch receptors, that is the cardiac receptors located in both sides of the atria at the veno-arterial junction. That is, in Bain-Briggs reflex is initiated by increase in blood volume in the atrium, and due to increased blood volume in the atrium there is a stretching of the atrial wall. This stretching of the atrial wall also stimulate SA node, and also due to larger volume of blood into the atria, according to Frank Starling law, there is increase in heart rate. Bain-Briggs reflex, that is increased venous return, causes a stretching of the atria, thus increase in heart rate. Frank Starling law of the heart, you know that within physiological limit, greater is the amount of blood in the heart, greater will be the force of contraction of the heart. That is, in heart, when there is increased EDV, there is increased force of contraction and increased heart rate. Now, one French physiologist, Marie, contribute greatly to the development of the experimental physiology. In 1860, he invented the sphygmograph, an instrument for recording the features of pulse and variation of blood pressure on a graph. That is, one of the French physiologists named Marie, he invented a he gave a statement regarding the relationship of pulse and the blood pressure, and he shown it in drawing a graph. Now in 1861 he formulated the Marie's law. He was the first to realize the relationship between blood pressure and the heart rate. Statement in physiology. What is the statement regarding physiology? Heart rate is related inversely to the blood pressure. Exception: exercise, emotion, and hypoxia. That is one of the very important statement by a renowned French physiologist, that is Marie. He stated that heart rate is inversely related to the arterial pressure. That is, when there is increased blood pressure, then there is decreased heart rate. Exception: exercise, emotion, and hypoxia. That is, in exercise and emotion, there is increased heart rate, there is increased blood pressure. Now this statement, that is heart rate is related inversely to the arterial pressure, you just remember about the baroreceptor reflex, because when there is decreased blood pressure due to baroreceptor reflex, there is increased heart rate, or when there is increased heart rate, the baroreceptors are stimulated and there is decrease of heart rate. Marie's law. Increased blood pressure which stimulate baroreceptors, and due to stimulation of baroreceptors, afferent impulses goes through 9th and 10th cranial nerve, and that stimulate the nucleus tractus salutaris, that is stimulate vagus nerve, that is decreases heart rate, and stimulation of the nucleus tractus salutaris, that inhibit vasomotor center discharge, and which decreases heart rate and decreases sympathetic discharge and heart rate. That is, when there is increased blood pressure, there is stimulation of the vagus nerve, and at the same time there is inhibition of the vasomotor center discharge. As a result, both of these effect, that is decreased blood pressure. On conclusion, heart rate and blood pressure have an inverse relation. This is known as Mary's law. Now, chemoreceptor reflex. Low partial pressure of oxygen, high partial pressure of carbon dioxide acidosis. They stimulate chemoreceptors, and this stimulation goes through the afferent via 9th and 10th cranial nerve, and that stimulate the nucleus tractus salutatorius, and this also stimulate the vasomotor center, and there is increased heart rate. That is conclusion, baroreceptor reflex. Due to baroreceptor reflex, there is decreased heart rate, and due to chemoreceptor reflex, there is increased heart rate. Stimulus is for chemoreceptor reflex, low partial pressure of oxygen, high partial pressure of carbon dioxide, and acidosis. Now, summary. What we discussed in our lecture, that is, what is heart rate? You already know that is the heart rate, that is the rhythm or cardiac cycle in 1 minute. Number of rhythm or number of heart rate in 1 minute. This is the heart rate. Normal heart rate 60 to 90 beats per minute. Now the maximum heart rate, that is, it is the maximum capability of the heart in exercise. In healthy young adult, it is about 200 beats per minute. This 200 beats per minute of maximum heart rate, it is also called the permissive level of heart rate. Now the factors affecting heart rate, you know that it is age, gender, respiration, and reflexes, and the intracranial pressure. These factors affect heart rate. Regulation of heart rate, you know, it is extrinsic regulation and intrinsic regulation. Extrinsic regulation by nervous regulation, regulation by reflex, and also regulation by humoral factors. And intrinsic, that is due to intrinsic properties of the heart, that is Bainbridge reflex, and another is Frankenstein law of the heart. These are the topics we discussed all. Now, thanks for your attention. Thank you very much. Okay.